Hi everybody, we're doing 1.3a today and we're going to focus more on how to describe center. Here are your learning objectives. So there are two main ways we're going to talk about center in this class. There's actually quite a few different ways to talk about center in a distribution, but we're going to focus on the mean and the median. So the mean, very common, probably the most common way to measure center. It's the average of all of the values. You're going to see this symbol used a lot. It's pronounced X bar, and it is the average of all of the observations in a set, which, if you need a quick reminder, you add up all the values and divide by how many values there are. In math, the Greek letter sigma is shorthand for add it all up. So I can summarize this formula with this. And this is actually something on your formula sheet. It means add up all the observations and divide by how many there are. Another way to measure center is the median. So the way median works is you find the value that is in the middle of all of the other values. To do this quickly, line up all the values from least to greatest, and if you have an odd number of items, then the center observation is the median. So a quick example, if you have 3 items, this is the center one. If you have an even number of items, then let's say you had 4 items, you would average these two together, the 2 middle ones, for the median. Even though the mean and the median both measure center, they measure it in different ways. So both are useful in their own way depending on the context of what you're trying to figure out. So you can think of median as the average value and the median as the typical value. So if you see these words in a problem, use them as clues as to what type of center you should go with. In a symmetric distribution, the mean and the median are about the same. So if I tried to draw a quick visual, mean and median would both be in the center of a symmetric distribution. But if I had a skewed distribution, let's say something like this, the mean, because it's an average, the mean will be much more heavily affected than the median. The median will move a little bit, but the mean will move more with the skew. That means if you are trying to find a center value in a skewed distribution, you want to go with the median because of that reason. It's more resistant to skew. Here's a couple more examples of that. Some extremely skewed data, and you can compare the mean and the median here. This means even without seeing a graph, if I know that the mean is higher than the median, I know right away that the graph is skewed right, and vice versa for the other way. So again, here's a quick visual of why the mean is more affected by outliers and skew than the median. Alright, so let's try this. Use the data below to calculate the mean and median of commuting times in minutes of 20 randomly selected New York workers. So for the average, I'll just add everything up and divide by 20. I know that's how many there are for an average of 31.25 minutes. If I was doing this by hand, I would want to do this rather quickly. So stem plot's a pretty easy way to line up data in, from least to greatest when there's a large amount. And I can see here that there's an even number of things, so I'm going to average the middle 2 things together. I could count, right? I could go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 11 are my 2 middle values. So the average of those would be the median. Also, right away I can tell that this is skewed right because the average is significantly higher than the median. Measures of center by themselves can be misleading because they tell you where the middle is, but they don't tell you how spread out the data is. So I also want to look at something called the measure of spread, which in this case I could look at IQR. I think you guys saw this on your summer assignment as well, but I'll give you a quick refresher. The IQR is the middle 50%, so you need to find the first quartile and the third quartile, which is 25% of the data and then 75%, and subtract them. So let's try this for our example. Order it from least to greatest. I've got to average some values because of the even number. So the median, as seen before, was 22.5. Q1 would be 15. Q3 would be 42.5. So the IQR is 27.5 minutes. So that means the middle 50% or the middle half of travel times is 27.5 minutes. I can use this to identify outliers as well. So we're going to put a formal definition to outliers now. And it follows a rule called the 1.5 IQR rule. So you want to take your IQR and multiply it by 1.5. So going with our example, that means that 1.5 times 27.5 is 41.25. And then I'm going to take Q1 and subtract, and Q3 and add that value. So what I'm doing is I'm coming up with a range, right? Here's Q1, here's Q3, somewhere in here is the median. I'm coming up with a range of values that are not outliers. Anything past this, though, is outlier territory. So, going with our particular example, there was one value that I can officially say is an outlier, and that was 85 minutes. Here is your homework. Have fun.